Alright folks, we are at the point where we're learning about the errors in trapezoidal and Simpson's rule. So you guys had seen before that the trapezoid helps a little bit more than the rectangles because you get more of the shape in the background, but there's still a little error between using a trapezoid to calculate the area under the curve and using just the straight up integral. So this helps you see how far off you were with each shape. If you remember from before, the Simpsons rule is actually closer to the exact area than trapezoidal, but we're actually not going to use the formula for it. We're just going to have to use trapezoid rule because it takes a little bit longer. If you notice, the first one has a second derivative in it, and the Simpsons rule has a fourth derivative. So we are not going to do that. I wouldn't worry about it. My niece Violet is here to help. She is along for the ride. She is 8 months old and wants to help you out with your calculus. So we are going to go through the formula for error. Notice that your error is going to be less than a certain amount, which basically helps you to figure out what that value is. The area is approximating the integral, so that's why it's going to be less than the integral, because it's like the difference between them, basically. So if you think about the shapes, it's like less than what the shape would be exactly. So we're going to use our first example as 1/12 x to the fourth minus 2/3 x cubed with n equals 4. So we're going to use the formula as the sum, as the error is less than or equal to b minus a cubed over 12n squared. The parentheses inside that mean the max of the absolute value of the second derivative. So what I want you to quickly do is think about when we took the max of objects, what we were calculating. So think of like a parabola. The max of something was when the derivative was equal to 0. So if you're trying to figure out the max of f double prime, it's where the third derivative is going to equal 0, or where the endpoints are. So if you think about a function, it could be something like this, where you do something a little max and then it goes down again. So it technically could be the starting point. So what you want to do is actually calculate the max, basically the derivative of the second derivative, third derivative, where it equals 0, and then also plug in the endpoints. Okay, so we're going to throw that away. We don't need that anymore. We're also going to put Violet on the side somewhere. She's going to follow you a little, but not the whole time. Okay, so what we're going to do is first take the first derivative, which is 1/3 x cubed minus 2x squared. Take the second derivative, which is x squared minus 4x. That is what you're trying to calculate the max of, so that's the weird part. You want the max of this to see what the highest point is going to be. So if you thought about the trapezoids, would they fit nicely in that, basically? But to figure out the max of this, I need to take the third derivative, set it equal to 0, which is at 2. Now, these are the x values, so we need to figure out the y values that correspond to that. So what we're going to do is plug those in for your original function to see what the points are. Okay, so what we're going to do is plug in those points. So if you notice, I have it right here. So you have to do f prime of, f double prime of 2, because you're trying to find the max of that. F double prime of 1, again, because those are your end points of what we're looking at. 1 and 7 are. So what you should notice is that when I plugged in the x value, plugged in the 2 for the second derivative, because we're trying to figure out what the max value is of that, it was 4. And then I have to plug in both endpoints. Remember, that's the endpoints of your integral, so I had to plug in 1 and 7. When I plugged in 7 to my second derivative, it was 21, so that's the highest value I have. So that goes in for the max of your second derivative. It's the absolute value, so if you got a negative number, it would just turn into a positive. And that's because sometimes we actually end up with a negative area there. Then you plug in what you know. So we know that b is 7, a is 1, cube it, divided by 12 times n, which they'll give you, and multiply by 21. So your error in this was actually pretty high. Notice it was 23.625. A lot of times it'll be really small, which just basically means your shapes that you created with the trapezoids were very close to the exact area, whereas apparently for this function, they were not. Okay, I would like for you to try the next question on your own. So just remember the steps. Write down the formula first if it helps you. And then after you are done pausing the video and trying it on your own, I will show you how to do it. Okay, so it's really easy to get caught up in the first, second, third derivative of this. Just be careful that your derivative of cosine is negative sine, and then your derivative of sine is cosine again. So between the second and third derivative, it stays negative. You also pull out a pi because of the chain rule there. So you end up with pi squared and then pi cubed. When you take this and you set it equal to 0, the pi cubed goes away because you're dividing it. So it's where cosine of pi x equals 0. So you can inverse cosine both sides, and what will happen is you end up with pi over 2 equals pi x. So when you divide pi on both sides, you get x equals 1/2. So you're going to plug in the endpoints. So we have 0 and 1 that we plug in. We got 0 for both of them. So the max is actually pi squared, which comes out to be about 9.89, it looks like. So you plug that in for the max here. You have to do b minus a, when in this case it's 1, so it's 1 over 12 times 4 squared. So you end up with a super small error, which means that you're going to have a shape with sine of pi times x that if you use the trapezoid rule to find the area underneath of it, it's really close to the actual integral value, which is really convenient. Okay. I would like for you to, again, try the next one, but just be careful using the chain rule on this one. I would rewrite it as x minus 1 to the negative 2 first, and then evaluate. So again, pause the video. When you come back, I will have it done for you. All right, folks, so your error ends up being less than 1/4 when you do it all out. If you had trouble with that one, I can help you with it next time we see each other, or you can come see me during a free period. So you get error is going to be less than 1/4. All right, the next one, what they want you to do now is actually solve for n to figure out where your error is going to be less than 0.0001. So what that means is now you have the error that you want it to be less than, and you can substitute it in for the equation. So if your error is going to be less than 0.001, you're basically saying that that formula has to be less than the value. So plug in what you know again. I would use your answer from, we already did this question like 2 questions ago. So you can use the max that we calculated in that question, which was 21 if you remember. So you don't have to redo that process here. So you plug in what you know, 7 minus 1 cubed over 12n squared, but now we're looking for n squared. So your max was 21. You're able to plug that in as well. So we're at that next step. So then it's just math computation at that point. You're plugging in, you have 6 cubed times 21. You can divide that to both sides first if you want to, or you can cross multiply. I cross multiplied. So you get 0.001n squared is greater than or equal to 375. The reason we have it equal to is because we can actually round up at the end and make it work that it's going to be greater than or equal to it. So you can always just round up at the end and keep the greater than or equal to and not just greater than. So at that point, just a reminder, if you get to n squared equals a number, you don't have to worry about plus or minus here because you shouldn't have a negative error. That doesn't make sense in context here. So you only have to worry about the positive, and then again, round up even though it's 0.2 to be, n is going to be greater than or equal to 1945. Okay. If you would like a challenge, which is totally optional, you can try the next one. You will see why it is a challenge if you start it, most likely because the derivative, second derivative, and third derivative are going to be complicated. So totally optional for you to try if you'd like to, otherwise move on to the next part. Okay, so this is the last type of question we're working through, and it's basically estimating areas of irregular shapes. So my suggestion is with these questions, label everything you know first, especially knowing what n is. Okay, so n is the number of sections here, and in this case it's 6. The other thing that you should notice is that the endpoints are going to be 0, because notice that they're not like a height. It's literally endpoints, so you can't have a height there. And then this goes from 1 to technically 6. Okay. At that point, they want you to estimate using the trapezoid rule and Simpson's rule. So that's going to involve going back to the first set of notes that we had. So now you have enough information that you could try this on your own. If you want to work through it with me, you can. But I'm going to have the work shown in a second. So just try a little bit on your own first using trapezoid rule first. So we're going to use both methods, and then Simpson's rule. And again, Simpson's rule is going to be more exact to the actual area in this shape. But try them out, and then I'll have work done for you in a second. Alright, so you can see all of my work out. Remember, trapezoid rule is the b minus a over 2a times f of 0 plus 2f of 1 plus all of the other ones times 2 plus f of 6. So I showed the work for the multiplication and addition there, and it comes out to about 1,420 feet squared. And then again, remember, trapezoid is a little different than Simpson's. Simpson's has the b minus a over 3 times n times your first value plus 4 times your second plus 2 times the third, and so on. So you end up with a slightly closer area to the exact. I want you to use this idea to estimate the area of the one below this, but you're only going to use the trapezoid rule. Again, try to do your best about calculating the heights of those. If you have a slightly different answer than me, it'll just be because we are estimating different values, which is totally fine. Alright, so hopefully you got something close to what I got. I got 23,840 meters squared. Again, if you got something a little different, that's okay, because we're probably estimating different heights of each of those values. But remember, the first one is going to be this point, then that point, and so on. So remember, you use like the endpoints to help you calculate. It's also going up by 20s, so that makes it a little bit more challenging, but your n here would actually be 10, because you're going from 0 to 200, and you should have about 10 shapes. So, alright, last two. So again, I'm going to have you try the next question. If you would like to try the bottom one, great. It's not going to be something I check for you, but it's basically the same thing you've been doing, but it's in table format instead. I will give you answers to both of these when we're all done, but what I want you to do is, for the first one, just be careful, because they're asking you to figure out if 1 pound of fertilizer covers 200 square feet, estimate the amount of fertilizer needed in pounds. So when you get to your final answer, that's going to give you the area, but then you have to think about how many pounds of fertilizer you're actually going to need for that area if 200 square feet covers 1 pound. Okay, so again, try it out. If you want to try the bottom one, awesome. I definitely want you to try this one regardless, and then I'll have the answer up. Alrighty, hopefully you got about 89,000 feet squared. Actually, you should get exactly 89,000 feet squared. But then you have to divide it by, 200. And then, because that's your square footage that it covers. So you get about 445 pounds of fertilizer, which, if you've ever picked up fertilizer, it is super heavy. So hopefully they have a machine carrying it along the golf course, because that would hurt to lift that, unless you're like super into lifting weights, and then maybe you just want to try to lift pounds of fertilizer. Anyway, off my tangent. So hopefully you tried that one. If you tried the bottom one, it comes out to about 300 meters per hour, or mile, I guess it's miles per hour, it should be miles per hour. But also, funny notice, you're on a senior road trip and you went 90 miles per hour. Holy moly, that's crazy. So anyway, be careful on the roads there, folks. And I hope you have a great rest of your day. Bye.